Hello everyone and welcome back to Newton's Academy past paper review for grade 12. Today we'll be covering the math paper 2 topic analytical geometry, and we will be breaking down this question 4 that we have on the screen. So getting right into it, reading the question, it tells us in the diagram below, point A with the coordinates -1 and -3, point B and point C are the vertices of a triangle. P with the coordinates 2.5 and 1 is the midpoint of line AB. Line CA extended cuts the y-axis at point D. The equation of CD is y equals to -3x plus k. And the angle CAB equals to theta. And the angles alpha and beta are the angles that line AB and line AC respectively make with the x-axis. And then they've drawn for us a diagram, and the diagram has all the information indicated on it. So looking at question 4.1, determine the value of k, 2 marks, right? So 2 marks usually indicates quite a straightforward question. They want the value of k. We see that k is the y-intercept value in the equation of line CD, so this line here, and we do have a set of coordinates, so we can simply plug that into the y value and the x value, and then our only unknown is k, and we can easily solve for k that way. So let us solve for k. Question 4.1. So we have the equation y equals -3x plus k, and we substitute our two coordinates. So we had the y value -3 equals -3, and our x value was -1 plus k, making k the subject of the formula. We will then get k to be -6. Okay, right, quite simple, 2 marks. Okay, moving on to question 4.2, determine the coordinates of B. And looking at B, B lies on this line AB, and for the line AB we are given the coordinates of A, we are given the coordinates of P, which is the midpoint of AB, and the coordinates of B are unknown. So whenever you are given a line and you are indicated the coordinates of the midpoint and one other coordinate which forms part of the line which makes the midpoint, meaning it's equidistant from point B, A is equidistant, A and B are equidistant from point B. They are both the same distance away from point B. Then you can use your midpoint calculation to solve for the coordinates of that unknown point, even though both the x and y values are unknown. So let us show that by means of a calculation. So question 4.2, we are given the coordinates of P, and we know that the x coordinate of P is equal to the x coordinate of A plus the x coordinate of B divided by 2, and the y coordinate of P is equal to the y coordinate of A plus the y coordinate of B divided by 2. So we can simply go and substitute values for that. We know the x coordinate of P is 2.5, which can be written as 5/2, and then the x coordinate of A is -1. We want to solve for the x coordinate of B, and we divide that by 2, and we can do the same for the y coordinate of B. The y coordinate of P is 1. Can equate that. The y coordinate of A was -3 plus the y coordinate of B, which we are solving for, divided by 2, and when making each of those the subject of the formula, we get the x coordinate of B to be 6, and we get the y coordinate of B to be 5. Therefore, our coordinate of B can be written as 6 semicolon 5. And that answers the question. They wanted the coordinates of B. Okay, looking at 4.3, determine the gradient of AB. So we have the line AB. We know our gradient formula is the difference in y values over the difference in x values, and we can choose any two coordinates on that line, whether that's A and B, whether that's A and P, or whether it is P and B. So you can choose any two coordinates. We can use A and B. So 4.3, they want the gradient of line AB. And we know that the formula for gradient is the difference in y over the difference in x, and our y values, that's the y value of b minus the y value of a, and we have the x value of b minus the x value of a, and that leaves us with a gradient of 8 over 7. So that will be the gradient for the line AB. Question 4.4. Calculate the size of angle theta, 5 marks. So this question is not a single step calculation. We can see that because it's a 5-mark question, and also when looking at the angle theta, we can see that theta is not an angle in relation to a horizontal or to a vertical line. It is an angle between two lines which are at a slope. So we cannot determine that angle directly. We have to determine it by using its relation to other angles. So we see that theta is an angle within this triangle, and outside this triangle we have angle beta and angle alpha, and those are angles in relation to the horizontal. Beta is from the horizontal to line CD, alpha is from the horizontal to line AB, meaning we can use our angle of inclination formula to find the angle alpha and to find the angle beta, and once we have those, we can then calculate this angle as well as that angle, and then using sum of angles in a triangle we can then solve for theta. So let us go ahead and do that. And obviously we will need the gradients of each line. So we've already solved for the gradient of AB, and for CD we were given the equation. So we know that the gradient of CD will be negative 3. So that's the two gradients that we will use in this calculation. So 4.4. We know the formula of the angle of inclination is the tangent of that angle. So tan of beta is equal to the gradient of AD. That's just of AD, which is that line, or of CD, right? Either one. It's the same line, so tan of beta equals to the gradient of CD. And we know that the gradient of CD is equal to negative 3. However, whenever solving for your angle of inclination, we do not substitute negative values, we substitute positive values. So given the fact that the gradient is negative, we will have to take a reference angle. So solving for our reference angle, it is the inverse of the tangent of the gradient of that line, so negative 3, but we said we do not substitute negative values, so we substitute positive values, and taking the tangent of 3, the inverse of the tangent of 3, we get 71.57 degrees, and that is our reference angle. So obviously to get beta, our reference angle will be the angle, the supplementary angle, which is not beta. So it's that angle there. We can see that that is true because that angle is less than 90. So to get beta, we will have to subtract this angle from 180. So to get beta, beta will therefore be 180 minus 71.57, and that will give us 108.43 degrees. Okay, so that's the first step. The second step, we now need to go calculate alpha, and we already know the gradient of line AB. It's positive, so we won't have to solve for a reference angle. We can simply go ahead and state that the tan of angle alpha is equal to the gradient of AB. Therefore, alpha is equal to the inverse of tan of the gradient, which was 8 over 7. And this gives us alpha to be 48.81 degrees. Okay, so we've now solved for alpha, we have solved for beta. Now there are two ways we can go about doing this. We know that angle alpha will equal to this angle right here because of vertically opposite angles. So we can state that, and then we know that angle beta is the exterior angle. So angle beta should be equal to the sum of angle alpha and angle theta, and then angle theta is our only unknown, so we can solve for angle theta. An alternative method would be to go determine this angle here, which in fact we have already determined because we've calculated the supplementary angle of angle beta, and then we know that this is equal to angle alpha because of vertically opposite angles, and then we can use our sum of angles in a triangle to solve for theta. So let us go ahead and do that. So we know that angle, let us give it a name. We know that angle, okay, there's no alphabet to name it here, but we can call it, let's label this point, we can call it point E. So angle OEA is equal to angle OEA is equal to 71.7 or 57. Why? We have to give a reason. So that is vertically opposite angles, right? And then we have angle O, we can call that point F. OFA is equal to alpha. Angle OFA is equal to angle alpha, which is equal to 48.81 degrees. Again, same reason, vertically opposite angles. Vertically opposite angles are equal. Therefore, angle theta will be equal to 180 minus these two angles because of sum of angles in a triangle. So angle theta will equal to 180 minus 71.57 minus 48.81. The reason being sum of angles in a triangle. Therefore, angle theta is equal to 59.62 degrees. And we have now solved for angle theta. As you can see, it's a slightly lengthy calculation because we needed to first solve for two other angles to then solve for theta. Okay, looking at question 4.5, calculate the length of AD, leave your answer in third form. So they want us to calculate the length of A to D. We have the coordinates of A. The coordinates of D are not shown, but we in fact do have these coordinates. Why? Because we were given the equation of line CD and we solved for K. And we solved for K to be -6. Therefore, the coordinates of D are in fact negative or 0 and -6 because that is the y-intercept. Okay. Right. So they want the length of AD, so we simply use our distance formula or our length formula. So question 4.5, we know that the length of any line is equal to the difference in the x-coordinates at the end of that line squared plus the difference in the y-coordinates squared. So for line A, you simply substitute the x-coordinates of A and the x-coordinates of D. So the x-coordinate of D is 0 minus the x-coordinate of A squared plus the difference between the two y-coordinates. The y-coordinates of D was -6 minus the y-coordinate of A, which is -3. We square that, and when solving, we get the answer to be the root of 10. And they said leave your answer in third form, so there's no need to convert it to a decimal. You shall get your 2 marks. Okay. Question 4.6. If AC is equal to twice the length of AD, so that means AC, that length there, is equal to twice the length of AD, and AB is equal to the root of 113, calculate the length of CB. So they give us two sides of this triangle, AB and AC, and they want us to calculate the length of CB. We don't know the length of AC, but because we calculated the length of AD in the previous question, we can substitute that in this equation and get the length of AC. We've been given the length of AB. They want us to calculate CB. Now, when calculating the unknown length of a triangle, there's a few ways you can do it. either if it's a right angle triangle, you can use Pythagoras or your basic trig functions, sine, cos, and tan. However, we see this is not a right angle triangle, so we have to find another method, right? They want CB. We don't have any of the coordinates of CB, so we can't use distance formula. Therefore, we have to use one of our trig rules, meaning either the sine, the cosine, or the area rule. We can't really use the sine rule because we only have one angle of this triangle and we are not trying to solve for another angle. The area rule, we don't have the area, so we can't really do that. However, the cosine rule, we see that we have these two lengths and we have what is called the included angle. The included angle is an angle that is found between two known lengths of a triangle. So because we have two known lengths and we have this angle, the included angle, we can use our cosine rule to solve for CB. And in fact, this is perfect because CB is the length which is opposite our included angle. So let us go and calculate CB. So using our cosine rule, we simply write that out, that CB squared is always the length you're solving for, or the length which is opposite your included angle, squared is equal to the sum of the other two sides squared. So the sum of CA squared plus BA squared. Note that that looks a bit like Pythagoras, so when writing your cosine rule, you should always have this part that looks like Pythagoras, and then you subtract twice the product of the two sides which you are not solving for. So AC, which is CA, and BA, and then we have the cosine, which makes it the cosine rule of our included angle, which is theta in this case. So CB squared is equal to CA squared. We know CA is twice AD, and that will be 2 times the root of 10 squared plus BA squared, which they gave us as the root of 113 squared, minus 2 AC, which is again 2 times the root of 10, and BA, which is the root of 113. And then we have cosine, and we have the angle to be 59.62 based on our previous calculation. And when solving for that, obviously we need to square root CB because it's given as CB squared, and when solving for CB, we get that to be 9.22 units. That is the length for CB. Okay, and that concludes this question on analytical geometry. Thank you for watching.